Hello friends, this is Durga again from IT Varsity. As part of Oracle Performance Tuning, I will try to cover how to read AWR report and how to get some insights about the queries that ran in a particular point in time. So as demonstrated as part of earlier video, I have already changed the duration of my AWR snapshots to 15 minutes. So every 15 minutes a snapshot will be created, and to primarily showcase the AWR report, I have ran a similar query in two windows, one between 12:15 and 12:30, and the other one is 12:30 to 12:45. So as per between 12:15 to 12:30 I ran this query. So you can see that I moved the window to 12:15 to 12:30 time frame, and this is the spike when I ran a query. This one, insert into deck of cards in a loop. Okay, I will show you the script also. So I actually ran a script called a script like this, which will just loop 10,000 times and query from this table called deck of cards baseline, which have 52 records, and insert into this deck of cards table 10,000 times. So at the end of it, there will be 520,000 records in this deck of cards, because the same table is inserted into the data from the same table is inserted into this table 10,000 times. Okay, and if you see, it has ran the same query 10,000 times, and if you go back to the time window, you can see the insert command also, which is invoked by that PL SQL script. Okay, so typically most of the people try to look at the plan and see whether the query is good or bad. In this case, if you want to see the plan of this query, you can click on the plan, click on the table, and most of the people go by cost. In this case, it's 378. Okay, to insert this query, it's 1 minute. Okay, as this query ran 10,000 times, it is close to 520. It has inserted close to 520,000 records. This is an approximate number, but the main thing is cost is 378. Similarly, between 12:30 to 12:45 window, I have ran another run, which is similar to the query which we have seen. You can see this PL SQL execute, and the main difference is this insert append. Other than that, everything else is same. Okay, and if you go back and if you look at the query and click on the plan, go to table, you can see that cost is only 3. That one is 378 and this one is 3. The reason why there is a difference in the rows in the previous query and this query, let me see whether I was looking into the correct query or not in the previous window. So historical. So this is the previous plan using load table conventional, and the rows is 511,000 because because it was conventional, whereas with the direct path approach using insert append, you can see that the cost is only 3, whereas with conventional approach it has shown that it's 378. Okay, if you look at the plan of this one, you can see it has 3. So you might feel that this is better because the cost is only 3, whereas with the conventional approach it's 378. If you think so, you are absolutely incorrect. And if you see the uh, the looping of the query 10,000 times without append hint just took 2 seconds. Means when I ran the query, it just took 2 seconds, and even I ran just now also, it's you don't even see the spike here. So the insert statement happened here, and you can see that the insert statement is very quick. You don't even see the spike, whereas our insert statement with append, it took good 10 minutes. The same 10,000 inserts, just with the insert append with the append hint, took 10,000. So when we actually, what I am trying to say is, when we actually see the plan, there is a huge chance that it can give you misleading information. One of the best way to get the actual insights is by going to the AWR reports. As I have emphasized earlier, I have ran the 10,000 inserts without append hint between 12:15 to 12:30, and with append hint between 12:32 and 12:45. And as my AWR snapshot interval is 15 minutes, I will have 2 snapshots, and I can open both the snapshots and go through the details and see which one is better. So for that, I am clicking on snapshots, and there is this is the ending time, because it's a capture time. Capturing happens only at the end. So this snapshot with ID 63 is for 12:15 to 12:30, and this snapshot with ID 64 is for 12:30 to 12:45. So I am opening in a new tab both the things, and you can see here itself that 12:15 to 12:30 the DB block changes. When we say DB block changes, it's the blocks on the database files. There are 60,000, whereas here it is 159. Other than this insert statement, there is very lightweight operations happening on the database, all the system operations. No user operations are happening. So the main thing is, when we actually insert the data into a table, huge data set, it will be written into the database, and by looking at DB block changes itself, we can say that between 12:15 to 12:30 there are only 60,000 block changes, whereas between 12:32 and 12:45 there are 159,000 block changes, which means that insert append hint, even though cost wise it's only 3 compared to 378 for the insert without append hint, it is far more inferior than the insert with without append hint. Okay, now you can click on the report. It will just take a moment to generate the report. We will see both the reports side by side, and I will try to explain how to look into the report, and also what areas you have to look into, especially for this case. And depending upon the case by case basis, you need to focus on different aspects within the report, but I will try to focus only the SQL statistics predominantly as part of this demonstration, because we are comparing SQL queries. Okay, now both the reports are generated. So between 12:15 to 12:30, and the redo size is 110K. This is DB ID. I don't know. That's fine. So let me first let us confirm that this is 12:30 to 12:45. Okay, both open the same thing. Okay. So it opened the same report in both the windows. That's why I'm reopening it again. Yeah, this one is for 12:15 to 12:30. And you can see that redo size is 22,507 per second, whereas here it is 110,913 per second. Okay, it's in bytes, so the redo is more between 12:30 to 12:45 than 12:15 to 12:30. And on top of that, it provides a lot of information. You can start with load profile report summary. So this is a high level report about the IO, memory, redo, and all those things. And then you can see top 10 foreground events. So in this case, the top event is DV CPU, and here the top 10 is direct path write, because we use insert append, so it uses direct path write, and this is the top event in this case. And you can see that there is 388 seconds wait event. So everything is pointing to the issue of insert append. I'm not getting into the details why insert append is very slow. You can go through my other videos on that topic down the line, but here I'm only showing you how to read it and how to compare two reports in two different timelines where plans can give misleading information. Just focusing on plans can give misleading information. So top 10 foreground events or weight classes, everything is pointing to the issues related to insert append. Here user IO is more. Here user IO is not is sixth top event, whereas between 12:30 to 12:45 is the most top event. Like that, you can go through different aspects, and then you can go through the main report. So if you want to see how shared pool is performing, you can go to the shared pool statistics. If you want to see how memory is performing, you can go through memory statistics. If you want to see how IO is doing, you can look at the IO profile. These are all very high level information, and if you want to get into the main report, there is a tab called main report in that, and there you can see the report summary, SQL statistics, IO stats, which will give far more details than what we have seen. And then if you want to look at the rack level details, you can go to the rack statistics. Typically, if there are issues related to global cache, you can get into these things and you can sort out where the issue is. For now, we are primarily focusing on SQL statistics, and you can click on that in both the reports which we are looking into. And both the reports are actually you can see that there is a I mean, when it comes to SQL, the top SQL are the PL SQL script and the insert statement, in this case without append hint, and in this case with append hint. And you can see that the CPU time is 416 seconds when we use append hint, which is far more higher than the CPU time without append hint, which just took 2.38 seconds. So huge difference. The same query with just append hint in one run and without append hint in another run, there is a huge difference in the execution time itself. And then taking this SQL ID, so this is the SQL ID for our insert statement. You can actually search in the script and try to get more details about this SQL ID. What is the complete SQL query it is running? How many times it is executed? Let me go to the top and then search for it. So this is the first time it has encountered. By execution time, it took only 1.34 seconds, and then by again CPU time, it took 1.18 seconds. So out of 1.38 seconds, 1.18 is CPU time. And then it has this is by gets. means get means getting the data from memory. So as we are loading a very small table which is of 52 records, so only first time it will read from baseline table, and after that it will get from memory itself, and buffer gets 105,000 here, and then ordered by reads. It is not the topmost one of the top 2 or 3 queries. This is sixth query. It has only 2 physical reads because it is reading a very small table. So all the details you can get from this. Okay, and on top of that you can also see what's happening on the table level by just copy pasting this deck of cards. So you can see how many logical reads are there from the deck of cards, because it's using conventional approach. It has to read the blocks from the allocated storage and then perform the operations in memory. So there are 11 physical reads from this for this table. Okay, and then these are physical read requests. These are unoptimized reads. I mean, statistics are same, but they are categorized into different things. On a busy database, you might see different tables as top compared to other tables. But in this case, we are running on the same only one query, and they is not significantly different. And this is one important thing: block changes. There are 20,384 block changes when it comes to the insert statement without the hint. Now let's go to here, copy the SQL ID for the query which has the append hint between 1230 and 1245, and search for that query. The CPU time is 8.76, so the CPU time is not very bad, but the overall execution time is 398 seconds, so a lot of time it's spent on IO. Okay, so you can see the user IO time is 388 seconds, whereas previously it is very less. So like that you can get what's going on with that query, where it is consuming most amount of resources. In this case it's primarily IO, because insert append is a direct path load, and it's if there are any issues it will be with respect to IO. So you can go through all the statistics and compare. Now we will search for the tables, table name deck of cards, and see what is going on at the table object level. You can see that there are 230,232 logical reads, whereas here there are only 20,384 or even less. Where is that logical reads? Yeah, so when it comes to deck of cards it's 28,016, whereas here it's 233,232, because append hint has in each and every run of 10,000 inserts, it will reset the high water mark and allocate more and more storage. It will not try to use any blocks within the high water mark. That's the disadvantage of append hint, and I have covered elsewhere why this behavior as part of this playlist. So you can one of the important statistic is the block reads. We will go there, block changes, and you can see here that there are 81,152 blocks, whereas here it's only I think 20,000 blocks, 20,384 blocks. So each block is 8 KB, so it's around 11 MB overall when it comes to this one, whereas this one it's almost 80 MB. Okay, so that's how you can actually look into the AWR reports. You make sure that you have a performance tuning database and run a query particular in different windows using different approaches, and compare the AWR reports and definitely it will give a lot more insights than just comparing the plans. Comparing the plans and making the decisions can backfire in significant amount of times. Rather, you should actually run the load and start comparing the AWR reports to determine which approach is working better for you. That being said, I hope you are enjoying the content so far on my channel. If you like this video, please click on the like button. If you have any feedback or technical questions, please use the comment section of the video. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.